Today on the John Ankerberg Show, where did we come from? How did we get here? What brought us into existence? In most high schools and colleges, Charles Darwin's theory of evolution is presented as an established fact of science rather than a theory. But today, many leading scientists in their peer-reviewed literature are rejecting Darwin's theory for many reasons. One of the most important being the Cambrian explosion of animals, where complex, fully formed animals suddenly just appeared in the fossil record with no prior ancestors before them. Why do some scientists believe that these animals present compelling evidence of an all-powerful designing intelligence in the history of life? My guest today is Dr. Stephen Meyer, who received his PhD in the philosophy of science from Cambridge University, as the author of the best-selling book, Darwin's Doubt. We invite you to join us. Welcome to our program. I'm John Ankerberg. Thanks for joining me. Our topic is, why are many scientists today rejecting the standard textbook theory of evolution, known as neo-Darwinism, that we all learn in high school and college textbooks? And where did the problems with contemporary evolutionary theory begin? For the last few weeks, we've been looking at the theory of evolution and the scientific problems confronting it with scientist and philosopher Dr. Stephen Meyer. Dr. Meyer is a former geophysicist who received his PhD in the philosophy of science from Cambridge University. And he's written two best-selling books, Signature in the Cell and Darwin's Doubt. And Dr. Meyer, we're really glad that you're here. And here's your beautiful book, Darwin's Doubt. Tell me, what's the main point of the book?
Well, in the book, I describe a doubt that Darwin had about the adequacy of his own theory. And his doubt concerned an event in the history of life known as the Cambrian explosion. And we've been talking about it in previous episodes. The Cambrian explosion, again, is the event in the history of life in which the first complex forms of animal life arise very abruptly in the fossil record. And Darwin recognized that this challenged his picture of the history of life because he thought that complex life should arise gradually through a long process of small incremental variation accumulating over time. And instead what we see is the sudden appearance of these major forms of animal life. In the book, I talk about two mysteries. The first mystery is the mystery of the missing ancestral fossils, the ones that Darwin thought should be there to document that process of gradual change, but those are the ones that are missing. And then I talk about a deeper mystery, and that's the mystery of how the evolutionary process would have built these animals. And that mystery, I explain, has become very much more acute because of everything we've learned about the importance of information, in particular genetic information, for building new forms of animal life. And so the book has an overarching argument as well as a story, and that argument is that the theory of intelligent design provides a better explanation for the origin of the information needed to build these Cambrian animals than any of the current materialistic evolutionary theories or models.
Yeah, and today I want to begin with a clip from Illustra Media's beautiful documentary movie, Darwin's Dilemma, which asks, how could the complex animals in the Cambrian explosion suddenly come into existence? I want you to watch.
How did these new animal body plans and fundamentally new forms of life come into existence? This was the mystery that Darwin set out to solve. But everything we've learned in biology over the last 50 years has brought this mystery back with a vengeance. How do you explain the origin of the Cambrian animals seemingly out of nowhere? This isn't just a problem of explaining the absence of evidence in the fossil record. It's also a problem of explaining everything we know about life, right down to the level of molecules and cells.
The biological structure of a Cambrian trilobite was as complex and sophisticated as a modern crab. Its organs included a brain, gut, heart, and compound eyes. Each organ was constructed from specific types of cells. Each cell type was made from dozens of specialized protein molecules. And each protein was assembled from a 4-letter chemical code in a section of DNA called a gene.
Now, for the evolutionary process to transform a simple Precambrian organism like a sponge with 4 or 5 cell types into a Cambrian trilobite with at least 10 times that many different types of cells, that's a huge leap in complexity. And to make that leap, you need a vast amount of new genetic information. Where does that information come from? That's the central mystery of the Cambrian explosion.
According to neo-Darwinism, new proteins are constructed by the dual mechanisms of genetic mutations and natural selection. As the genetic instructions for building proteins are copied, an occasional error can alter their contents. If these accidental revisions prove beneficial to survival, they are selected or preserved and passed on to future generations. Over eons, these small changes accumulate, and new proteins, cell types, and even Cambrian carnivores gradually evolve into existence.
Richard Dawkins, the famous Oxford evolutionary biologist, has illustrated how the Darwinian mechanism works using a metaphor he calls climbing Mount Improbable.
From the front side, the mountain is a sheer cliff that could never be scaled in one giant leap. For Dawkins, this represents the impossibility of creating a complex animal by chance alone. Yet Dawkins also envisioned an alternative route up the backside of Mount Improbable, a long, gradually sloping trail of small steps leading all the way to the summit.
According to Dawkins, that's how you'd climb the mountain. And that's also how you'd build a Cambrian animal, one small step at a time. What chance alone can't accomplish in one blind leap, natural selection can accomplish through the cumulative effect of many small incremental steps.
In theory, each step corresponds to a small unit of biological change, a new gene and its protein product. But do mutations and natural selection have a reasonable chance of producing even one protein in the time available? Since 1992, molecular biologist Doug X has examined this question.
There's a story that's being told, and there's a appeal in the case of Darwinism to random mutation and natural selection as being, in vague terms, the mechanism. But if you look at the detail, what kind of mutation can accomplish these transitions? And there, it's important to realize that the one area where we can really nail this down is at the single protein level, where you can actually measure it. And if you look at protein structures, to get a substantially new protein fold is prohibitively difficult.
You know, Dr. Mayer, after watching that clip, Richard Dawkins and other evolutionary biologists are still confidently proclaiming that it's possible to build a Cambrian animal by natural selection and random mutation in small incremental steps. But what are some of the problems that you see with this evolutionary view?
Well, actually, many of the leading Cambrian paleontologists are now disputing that view. There's a paleontologist at the Smithsonian named Douglas Irwin, who has written a book with James Valentine from the University of California, Berkeley. And they take what they call a non-uniformitarian evolutionary view, which just in plain English means that whatever caused the Cambrian animals to emerge, it's unlike anything any biological process we see at work today, including the mutation natural selection process. So there's a lot of scientists who are doubting the creative power of the mutation selection mechanisms. One of the reasons for that is that natural selection can only select for a functional advantage, for an advantageous change in a protein or a gene at the smallest level. And yet we know that the odds of generating such a new gene or protein by random mutations alone is extremely small. And it's small even when we take into account the number of opportunities there are for such an event to occur given the known history of life on Earth. So the idea that mutation and selection have this amazing creative power is really increasingly being questioned. It does a great job of explaining small, minor variations in existing protein folds and structures. But if you need enough changes to build what's called a new protein structure, a new protein fold, Too many things have to go right before there's any selectable advantage. There is no gradual series of steps up the backside of the mountain. It's basically a big jump proposition where you need many coordinated changes to occur before there's any selectable advantage. And the number of coordinated changes that are required are so vastly improbable that it's far more likely, as we were saying in the last program, that such a mechanism will fail, such a random search will fail than it is that such a mechanism will succeed. So there are really important, I would say, mathematical reasons to doubt the creative power of the mutation selection mechanism with respect to the problem of building even one gene or protein, let alone a whole new Cambrian animal, which would require hundreds and thousands of new genes and proteins.
Well, let's show them a clip that illustrates this. This next clip explains why Darwin's theory of natural selection and random mutation cannot account for what is needed to build a Cambrian animal. Folks, I want you to listen.
Each of the thousands of different proteins in nature is actually a chain made from a specific combination of 20 different amino acids. The sequential order of these chemical building blocks is crucial, for if they are arranged correctly, the chain folds into a functioning three-dimensional molecule. But if the amino acids are incorrectly assembled, no protein will form. If proteins are indeed rare among the possible sequences of amino acids, what are the odds that mutations would stumble upon a functional combination of chemicals from the vast number of alternatives? To find out, Axe randomly altered the structure of an enzyme protein comprised of 150 amino acids.
You've got a protein 150 amino acids long, then you've got 20 to the 150th power possible ways of arranging the amino acids. Out of all those possibilities, how many are functional and how many are gibberish?
If you do the experiments and you analyze how much information is required to get, say, a new protein fold, it's just far beyond what you can get by random mutation and natural selection.
How far beyond? Axe published his findings in the Journal of Molecular Biology. He determined that among all the possible amino acid combinations, the probability of generating just one short protein by mutation is roughly 1 in 10 to the 74th power, or 1 chance in 100 trillion, 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 trillion.
To put that in context, there's only 10 to the 65 atoms in the entire galaxy. So to build a new functional protein by selection and mutation
Within the time allowed for the Cambrian explosion,
what you're essentially having to do is equivalent to a blindfolded man looking throughout the entire galaxy for one marked atom. So what we're talking about is searching for a tiny, tiny needle in an enormous haystack and having a very limited time to search.
So on the question of something like the Cambrian explosion, there does not appear to be any way that unguided random mutations can accomplish what needs to be accomplished to explain new functional proteins. And certainly by extension, wherever in the history of life you would need to have multiple new protein folds, the probabilities multiply. So there's no reason to think that this is plausible.
Dr. Meyer, that's really impressive. Do you have another way of illustrating what we just saw?
well, we talked in the last episode about a bike lock as an illustration. You have a thief who wants to perform a random search to find a combination in order to steal a bike. He comes up against a big hurdle, and that is the number of combinations that have to be searched. In a 4-dial bike lock, you have 10 digits on each dial, so you've got 10 times 10 times 10 times 10, or 10,000 possibilities that have to be searched. And but depending on how much time is available, it could either be plausible that the search will be successful randomly, or implausible. What Axe has shown is that in the case of even a single gene or protein, Douglas Axe, the scientist that we saw in the last clip, is that in the case of even a single gene or protein, The number of dials that we are effectively looking at is about 74, there's slight differences in his estimates depending on the method he uses, where you've got 10 possibilities at each dial. So that's an enormous number of combinations that correspond to that. That's 1 in 10 to the 74th power combinations. Now, that number is so big, it's many orders of magnitude greater than the number of atoms that exist in the Milky Way galaxy, that you can see that you would have to be looking a long, long, long time by random means to sample more than half of those possibilities. Once you get beyond half, then you could say it's more likely that you'll succeed than you will fail. But because the number is so big, there's so many possible ways of arranging those amino acids or the letters in the DNA code that would correspond to building those proteins, that it's even on the scale of cosmic time or on the scale of the history of life on Earth, you're going to not have nearly enough time to sample but a tiny fraction of that total number of combinations, which means it's going to be overwhelmingly more likely that a random search will fail to find even a single functional gene or protein in the known history of life on Earth than it is that such a random search will succeed. And if it's overwhelmingly more likely that a random search will fail to find a new gene or protein, fail to generate new genetic information, then the hypothesis that such a search succeeded is actually more likely to be false than true, in which case that's a bad hypothesis and we should reject it.
In this next clip, we're going to show the problem only gets worse, okay? Because scientists have discovered something else. And this was amazing when I watched this. They discovered the body plan for an animal does not reside in DNA. So where is the information of each animal body plan stored, and where did that information come from? Folks, I want you to watch this clip.
But the inability of random mutations to generate new genes and proteins is only part of the problem. For the origin of Cambrian body plans demanded more than new genetic information.
A lot of the information for specifying an anomalocaris, a trilobite, what have you, it does not reside at the DNA level.
The body plan, as far as we know, is not in the DNA.
While DNA carries the instructions to manufacture proteins, it cannot alone assemble them into cell types or arrange cell types into new tissues and organs, or tissues and organs into body plans. Instead, the formation of body plans ultimately requires another level of information stored somewhere in the three-dimensional structure of the egg cell and the embryo. Instructions that direct the development of complex animals from fertilized eggs. With computer animation, we can observe this intricate process. As an egg cell begins to divide and differentiate, a network of biological commands orchestrates the development of an arthropod. After several stages of division, dozens of new cells align against the outer membrane of the egg. And then, cued by a chemical signal, they start their migration toward targeted areas in the embryo where they will gather and develop into a mature organism. The cells steadily increase their numbers and align, like members of a marching band, into patterns that will form the tissues and organs, head and legs of the growing embryo.
That happens by a process of cell specification and differentiation, where cells are committed irreversibly to performing particular roles. You're going to give them different jobs to do. You're going to be part of the locomotory system of this organism. You'll be an eye, you'll be a gut, and so forth. To me, that's an absolutely astonishing process, but it works. And what it builds you is different kinds of organisms depending on the instruction set that's provided.
So there is an organismal blueprint, an ultimate point that the embryo hones in on and is attracted to and eventually embodies.
that foresight, that preordained outcome is built into the embryo.
When you talk about these early developmental sequences, and anomalocaris and Hopivinia, what have you, you're talking about information in the broad sense, codes, specifications, entailments, implications that are orders of magnitude beyond anything that we can currently conceive. It's so off scale that you've left that line of impossible by chance a long time ago.
The volume and complexity of information that controls the development of a body plan is staggering, and its location in the cell stands as perhaps the ultimate challenge to the neo-Darwinian scenario of random mutation and natural selection.
We know that much of this higher level information that's required for building new tissues and organs and body plans isn't found in DNA. That means that you can mutate DNA indefinitely without respect to probabilistic limits, without respect to time and number of trials, and you're never going to get the kind of form and structure you need to build a new organism. DNA is simply the wrong tool for the job, and no amount of time is going to overcome that limitation. That has a really devastating implication for the neo-Darwinian mechanism.
If the Darwinian mechanism cannot explain the origin of the information necessary to produce the Cambrian animals, is there any other cause that can?
So, Dr. Meyer, help us understand this a little bit more.
This last problem that we saw explained in the film is really a very profound and fundamental problem in modern biology. According to neo-Darwinism, new form arises as a result of new variations, and the new variations occur as a result of mutations in the DNA. So the ultimate source of new biological form are changes in the arrangement of those A, C's, and G's in the DNA molecule. But what developmental biologists are learning is that DNA is only part of the story. It provides a necessary amount of information for building proteins, but that information is nowhere sufficient to build a whole animal, because the proteins have to be arranged into structures within cells. Different types of cells have to be arranged to form tissues. Different tissues have to be arranged to form organs, and organs and tissues need to be arranged to form whole body plans or architectures, where a body plan is a unique arrangement of body parts and tissues. So DNA is necessary but not sufficient. Now, if we think of that in light of what neo-Darwinism says, it says that the source of new form and structure in a biological system, a new body plan, is going to come from variations in the DNA. But if the DNA only provides the information for building proteins, and other levels of information are necessary to arrange the proteins, the cell types, the tissues, and the organs into a whole body plan, then you could mutate DNA indefinitely, and you will never build a new organism. The technical way of saying that is if body plan building or body plan morphogenesis depends on information beyond DNA, then mutating DNA is never going to get you a new body plan. It's not the right tool for the job. Now, I first learned about this in a technical book published in 2003 by MIT Press that was co-edited by two leading evolutionary biologists. And in the introductory article to this book, in which they explained this problem of the higher levels or the epigenetic information, they acknowledged that neo-Darwinism was still the standard textbook theory, but they said that neo-Darwinism has no theory of the generative. That is to say, it can't explain the big changes in the history of life. It doesn't explain the origin of body plans. Now, one of the things that struck me about reading that book and the many articles that were elucidating the difficulty of this problem is that there's a huge disparity between the public presentation of the status of evolutionary theory as we find it in our biology textbooks, as we find it presented by people like Bill Nye the Science Guy, or by Richard Dawkins, or by defenders of the Darwin-only approach to science education on the one hand, and the actual status of evolutionary theory as we find it in the peer-reviewed technical literature in evolutionary biology, where many evolutionary biologists are now saying very openly that neo-Darwinism is dead and we need to find a new theory of evolution. And so one of the things I did in my new book, Darwin's Doubt, is first of all, I exposed this disparity and showed that the popularizers are out of date and what they're telling the public is simply false. And I also looked at the many new theories of evolution that are being proposed to replace neo-Darwinism, I examined them and then also critiqued them and showed that they too fail to explain the origin of the genetic information in DNA that you would need to build Cambrian animals, but also this higher level epigenetic information. And so there really is a crisis in evolutionary theory today, one that started way back in 1859 when Darwin honestly acknowledged the problem of the Cambrian explosion. But in the book I show that that problem has become much deeper and more profound as we've learned more about what it takes to build an animal. We need both genetic and epigenetic layers of information, and there is no evolutionary model today that accounts for the origin of that crucial information and therefore the origin of these Cambrian animals.
All right, Stephen, I want to talk about the positive side of this. We've been talking about the negative side. What's the alternative that we can go to?
Well, I'm a proponent of the theory of intelligent design. I think what we're seeing in this digital code in DNA and in this hierarchically organized information processing system, which is what an animal is, I think we're seeing positive evidence of a designing intelligence acting in the history of life, and we will maybe talk about that in some of the upcoming programs.
All right, folks, I hope that you'll join us next week. Well, thanks for being with me today. If you enjoyed today's program and would like to watch it again or wish to view some of our other programs and topics, just go to our free John Ankerberg Show app or watch it at our website at jashow.org. Again, you may watch any of these episodes free on our John Ankerberg Show app, or you may download each episode for your personal use for only $5 an episode at our website at jashow.org. Folks, our goal is to help encourage and strengthen you in your walk with the Lord. And possibly God is speaking to you today, and you'd like to know how to become a Christian, or you'd like to pray and invite Jesus Christ to be your personal Savior. If so, just go to our website right now and click on Become a Christian, which you'll find at the top of our homepage. There we will tell you how you can pray and ask the Lord Jesus Christ to be your Savior from sin, and how you can know Him and experience Him personally. We're glad that you have chosen to watch our program today, and hope to see you next week as we present another program intended to encourage and inform you as you walk with the Lord each day. Goodbye, God bless you. I'll see you next week. God is speaking to you today. And if you would like to have someone pray with you, or you have a question you would like to ask, there's a phone number on your screen right now that you may call. Call that number, and someone will be happy to pray with you. Thank you for joining me today. I hope that you'll join me again at the same time next week. And to learn how to start a relationship with Jesus Christ, go to our website at jashow.org and click on Pray to accept Jesus Christ as your Savior.